Oops, I forgot to record. There we go. Scientific notation is a way to write very big or very small numbers. Scientific notation, it's used a lot in science. When scientists are talking about, the diameter of a skin cell, it's a really small number. When scientists are measuring the weight of something that's really heavy that I can't think of, that's a really big number. The estimated weight of all the people in the state of Kansas. It's a really big number. Right, so really big or really small numbers. Numbers that you and I cannot read accurately. For example, that's 12 zeros, not including the leading one. That's a really small number. I mean, if I was even going to attempt to read it correctly, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, billionths, 10 billionths, 100 billionths, trillionths, 10 trillionths, 100 trillionths. It's too, right? That's too much. Right? We're getting into numbers that it takes too long to read this number correctly. And it even takes longer. Haley, face the front. It takes even longer. I wouldn't want to say 0.00000000000000134. That takes too long. That's a really small number. Could I figure that number out? Yes. But it takes too long to read it. It takes way too long to read it. So they use scientific notation to express it, to give you an idea of how big that number is. I guess typically these would all be zeros, not regular numbers, if we're going to make life easier. But even then, even making all of those zeros, it's still too big of a number. I don't want to have to stop and count my places to figure it out. So here's how you work in scientific notation. If you have a really big or a really small number and you want to write it in a better way, you use scientific notation. These numbers right here, they're regular numbers. These are called standard notation. That's the regular, everyday type of numbers we work with. Standard notation. 42 is standard notation. $84 million, standard notation. We think of them as regular numbers. So follow these rules. Are you ready? To write a number, so converting standard notation to scientific notation. That's one of our goals today, converting standard notation to scientific notation. On your homework, you will be asked to do this. Step number 1. Find the decimal. In that first number that I wrote, can you find the decimal? Where is it? Right here. Found it. Step number 1's pretty easy, right? In that second number, I don't see a decimal. It's at the very end. It's hiding. Step number 1, find the decimal. Step number 2, move the decimal so there is one non-zero digit to the left. Move the decimal so there is one non-zero digit to the left of the decimal. Move the decimal so there is one non-zero digit. Very important. To the left of the decimal. Ladies and gentlemen, this is the part in life where it hurts my heart. Please raise your left hand. Think about it. There you go. Your left hand makes the letter L, right? Okay. Everybody knows which side is the left, correct? Left hand. Most of you are right-handed, so for the trick is it's not the hand you write with. However, for those of you that are left-handed, it is the hand you write with. Left. Move the decimal so there is one non-zero. What does non-zero mean?
Non-zero.
It cannot be zero. Digit to the left of the decimal. So here we go. Here's my decimal right here. And to the left, is there a zero? So I have to keep moving it. Is there anything that is non-zero on the left side yet? Nope. Do it again. Nope. Keep going. Nope. Keep going. I'm going to keep moving until there... Should I stop right here? Is there anything to the left that is not zero? Keep going. Right there. That's where I stop. Because there is one non-zero digit to the left. The digit is 1. That's my non-zero digit. So my new decimal place is right there. All right, let's try on the big number. Where's the left? I only want one non-zero digit, and there's a whole bunch of digits, aren't there, to the left? All right, so I want one non-zero. So here we go. Should I stop here? How about now? 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 Here? How about here? Right now? Am I done yet? How about here? How about here? How about here? Some people are going to want to stop here, but how many digits are to the left? 3. Now how many digits are to the left? 2. Now how many digits are to the left? There is 1 non-zero digit to the left. One non-zero digit. My non-zero digit is 4. You move the decimal so there is 1 non-zero digit to the left of the decimal. Step 3. Let me clear that up so you can actually tell what I said. Write the new decimal. So if I look for the first number, these zeros, do they matter to anything? No, those zeros don't mean anything. If they were inside this grouping, yes, I'd care about them. But they're in front of it, so I don't care. So my new decimal is 1.34. 1 and 34 hundredths. 1.34. Because that's scientific notation. We're going to add something to it. We're not done yet. But scientific notation, it's a whole lot easier to say 1.34 than to read this, isn't it? Dakota. What's this new decimal? 4.87. 4.87. Step number 4. Count the number of moves you made count the number of moves you made. This number is the exponent. So if I look up here, for this first number, how many moves did I make? 12. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'll double count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my exponent here is 13, little tiny 13 up top. Is this a big number or a small number? It's pretty small. So what do you think I should make that 13? Should it be positive or negative? It's a small number. Let's make it negative. All right, is this, let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my exponent is 14. Is that a big number or a small number? Big number, so let's keep it positive. And ladies and gentlemen, do you know how to make the decimal move one time whenever you want? What do you multiply by to make the decimal move one time no matter what? Not 1. 1 doesn't move at all. You multiply by 10. You write in scientific notation. So scientific notation is a decimal times 10. 1.34 times 10 to the negative 13. Because what kind of number is this? Big or small? Small, so it's a negative exponent. This number is 4.87 times 10 to the 14th power. Why is it positive 14? Because it's a big number. All right, let's practice. Are you ready? Here's an example. 8694000. I'm not making them huge because I don't want you to have to worry about it. So follow your steps. Step number 1, find the decimal. Where is it? At the end. Step number 2, move the decimal so there is one non-zero digit to the left. Right now I have 1, 2, 3, 4, 5, 6, 7, 8 numbers to the left. Some people are going to stop right there. How many digits are to the left? 4. We only want 1. Right there. Write the new decimal. Count the number of moves you made. 1, 2, 3, 4, 5, 6, 7. Carson, is it positive 7 or negative 7? Why positive 7? Because it's a big number. Nope, because the exponent goes on your 10. It tells you how many times you move your decimal. Moving your decimal one place is like multiplying or dividing by 10. Times 10. 8.694 times 10 to the 7th power. Try this one. Everything is times 10. Zero 0.0000706. I'll say it again. 0.00000 5 zeros 706. Step 1, find the decimal. Do you see it? Found it. How many digits are to the left? How many non-zero digits are on the left? There's 1 0, but I have to keep moving it. So which way do I move it? I go this way. Should I stop? Nope, because those are both 0. I want non-zero. How about now? Here? How about here? How about here? How about here? Yes. 1 non-zero digit to the left. 7 is to the left. 7.06. Nope. Count how many moves you made. 1, 2, 3, 4, 5, 6. But 6 is not my answer. Why negative 6? Because it's a small number. Is that my answer? All right, let's work backwards. Let's see if you can figure this out. I want you to convert from scientific to standard. What if I gave you this number? What if I said 8.43 times 10 to the 5th? Could you tell me the answer? Could you tell me the real number? Dakota, turn your body. Could you tell me the real answer to this? The standard number, the real number. What do you think we'd start with? Oriah, what are you going to do? I'm going to make it a big number, right? Because it's 5. So I'm going to move my decimal 5 times. 1, 2, 3, 4, 5. That's my answer? So fill in with zeros. I like to then rewrite it because that doesn't look like a real number. 8, 4, 3, 0, 0, 0. That's my answer. All right, smart kids, try this one. .304 times 10 to the negative 6. It's kind of the same idea, but it's totally different. It gives you a totally different kind of number. I'll start with my decimal again. 4.304. And Ariah told me I'm going to move my decimal 6 times. So is it exactly the same? What's different about this problem? Tyson? It's a negative exponent, so what does that mean? It means it's a small number, right? So I'm not going to make the number bigger. I'm going to make the number smaller. So I move it 6 times. 1, 2, 3, 4, 5, 6. Is that my answer? Fill it in with zeros. Dakota. Rewrite it. 1, 2, 3, 4, 5, 4, 3, 0, 4. Some of you are going to have a personal preference and say, I don't like the way that looks. I'm going to put a 0 in front of it, and you can totally do that. That's an extra add-on. This answer will work. If you don't like the way that looks, you can put a 0 in front of it, and it's totally fine. Your homework tonight is converting. What if I told you this number was an answer? What if you put that down as an answer for your homework and you got it back and there was a big old red check mark next to it? It means you got it wrong. Why? Hold on. Think about it. Right here. You did your homework. It was perfect. This was your answer. And there's a check mark next to it. And you're like, ugh! What happened? Why did I get this wrong? Evangeline, why did you get it wrong?
Because there's two numbers, there's two non-zero numbers.
Perfect. The answer should have been 1.434 times 10, and instead of 5, I had to move it one more time, so it would be 6. Good job. Please make sure there is only one non-zero digit to the left.